April 23rd, the Swift Multi-Wavelength Observatory, orbiting the Earth, recorded a GRB that occurred 13 billion light years away from Earth, near the very edge of the visible universe. The blast occurred only about 630 million years after the Big Bang. This means that gamma rays from the exploding star traveled at the speed of light for 13 billion years before they were visible to us, making this gamma ray burst the oldest stellar object in the known universe.
No star or galaxy that's farther away than this gamma ray burst. It's the single most distant discrete object ever seen.
At only 8,000 light years, a GRB blast from Wolf-Rayet 104 could be catastrophic.
The flash that we would see if Wolf-Rayet 104 went off would be much brighter than the sun. Gamma ray energies. A single gamma ray burst can easily exceed light output of millions of galaxies. And each of those galaxies contains 100 billion stars.
This Death Star is a ticking time bomb. Scientists know for sure it will go supernova. But questions remain about its potential to unleash a gamma ray burst in the direction of Earth.
That's the first point we need to establish. If it does produce a gamma ray burst, is that gamma ray burst pointing towards us?
The spiraling axis of the star appears to be aimed in the direction of Earth. Light years to travel. Would the GRB beam actually hit the target? Does aim be true?
We know it's pointing roughly toward us, but it could be pointing sufficiently away from the gamma ray burst. If it turns into a gamma ray burst, will actually miss us.
The star is aligned. One powerful burst of energy could turn the Earth's ozone layer into a radioactive inferno.
Even a gamma ray burst light years away could deplete the ozone layer of its current level. Now that won't kill all of the species, but it could lead to extinction, or a good fraction of all living species die rather suddenly.
The question is, will the death of WR-104 really trigger a gamma ray burst? Just don't know. Requirement for a star to produce a lethal gamma ray burst: horsepower rotation. All stars rotate on their axes. Stars can spin very fast.
So the rotating star, the rotational energy produces the gamma ray burst.
If you can put the brakes on a rapidly spinning star and slow it down before it gets to that stage, you've defused that bomb.
Based on mounting scientific evidence, it appears the universe itself is applying another set of brakes to its stars. It's called metallicity. Stars are primarily made of hydrogen and helium. More complex elements are created every time a star explodes. Elements like carbon, nitrogen, and oxygen that then become the raw materials for the next generation of stars. So a star born today has more heavy elements, also known as a higher metallicity, than a star born earlier in the history of the universe.
Star has a lot of heavy elements in it. It tends to lose a lot of its mass through winds. And if it loses a lot of its mass, it also loses a lot of its rotation. It ends up rotating too slowly to form a GRB.
So something is happening to the Wolf-Rayet stars today and defusing all the bombs. So they're still blowing up as supernovae, but far, far fewer of them are taking that supernova to the next step as a gamma ray burst.
Could these breaks slow WR104 enough to render it harmless to the Earth? Many astronomers believe so. What if they're wrong? At 8,000 light years away, is Earth really in the danger zone? When the Death Star, called WR104, finally explodes, it has the potential deadly gamma ray burst directly at Earth. It's believed the star is roughly 8,000 light years away from us. Is this close enough for a gamma ray burst to do damage to our planet?
Being 5,000 to 8,000 light years away, Earth's life might take a bad hit if it reaches us.
If it was further away, we'd probably be okay. And if it was 2 or 3 times closer, we'd really be shaking in our boots. But it's just at the edge of its range where one would expect, well, you know, but it's probably not going to roast us all in our sleep.
Perhaps once every billion years or so, burst that's sufficiently close and sufficiently well pointing toward us that we need to worry.
Death stars of all sizes populate the universe. The only entities capable of such violence. The universe is also home to death galaxies. 21, also known as the Death Star Galaxy.
3C321 is a galaxy with a giant black hole in the middle, millions of times the mass of our sun.
Just outside the black hole's edge, the chaotic churning of magnetic fields and gravitational pull has ignited a high-energy particle jet. These jets are not uncommon, but this one is delivering a beating to its nearest neighbor.
The case of 3C321 is very interesting because there happens to be another galaxy 20,000 light years away. The stars in that galaxy are being blasted by the energetic particles and radiation from one of these jets.
X-ray astronomer Dan Evans has been tracking the Death Star Galaxy and its violent behavior at the X-ray Satellite Control Center outside Boston.
So we see black holes do kind of strange things, but only a very small fraction emit these powerful jets and particles. And a fraction even smaller, such as the 3C321 galaxy, the Death Star galaxy, smack into other companion galaxies. So that's incredibly rare.
The companion galaxy is across the galactic street, 20,000 light years distant. A massive energy beam, even larger than a gamma ray burst from a dying star, is firing non-stop with a seemingly limitless energy supply.
Looking at here is the best terrestrial analogy for the Death Star galaxy, 3C321. A jet is racing out of the black hole, close to the speed of light. It's actually normally would propagate up to around 1 million light years away. But in the special case of 3C321, coming into the side of the companion galaxy. And in doing so, it's becoming disrupted and distorted and bent away. And that's wreaking all sorts of havoc for that companion galaxy.
Much like the building is deflecting the water jet, the planets and stars in the victimized galaxy are deflecting most of the attacking particles.
So this jet is actually a massive beam of energy and particles. And these particles have been superheated such that they form a plasma.
Plasma is a mix of super hot, charged electrons and ions funneled into the jet by the black hole's immense magnetic field.
Jets that race out of black holes are actually incredibly energetic. And in fact, they can accelerate particles such that they emit light, maybe even up to gamma rays. These rays are incredibly powerful.
And very long-lasting. Some estimates say the energy jet from the Death Star galaxy has been firing for nearly 2 million years. For its fuel, 3C321 simply devoured an entire galaxy.
A lot of fuel. What we actually think is happening here is that there's been a previous merger. So another galaxy has fallen in to the main galaxy. We see this beautiful dust lane, which implies that the galaxy has been shredded already. And so that drives mass down into the black hole.
After consuming another galaxy's provision of plasma particles, the Death Star galaxy has to somehow energize the particles into a jet. Black holes have powerful magnetic fields and super fast spin rates, a combination that somehow ignites the particle jet. Scientists believe the reason the jets fire in one direction is dust and gas circling the black hole.
In the case of an active galaxy like 3C321, which has a supermassive black hole in the center, you often have a donut or torus of material surrounding it. Highly energetic particles near the black hole can't emerge from that region through the donut along the plane of the galaxy. They can only emerge along this axis where there's relatively little obstructing material.
Unfortunately for the companion galaxy, it's staring straight down the donut hole. Zone of impact is like the widely scattered blast of a cosmic shotgun.
The problem with this jet of high-speed particles and radiation galaxy 20,000 light years away is that the jet is wide enough to encompass a large number of stars in this galaxy. So any creatures living on any planets, orbiting any stars in that galaxy are in serious trouble right now.
Our own Milky Way being blasted by the Death Star galaxy. Put Earth in the path of the jet, and the effect on the ozone layer would be enormous and deadly.
The gamma rays 21 convert nitrogen gas into nitrous oxides. And it's those nitrous oxides that actually act as a catalyst in the destruction of ozone. So within a matter of weeks to months, maybe up to a year, the ozone layer will be completely obliterated.
But like many phenomena observed there is a recurring paradox. From death comes life. 21 not only destroys, it also creates.
So one of my favorite things about 3C321 is it demonstrates really clearly that black holes don't just gobble everything up in the universe. They're not all complete harbingers of destruction. The jet that is coming out of 3C321 is hammering into the side of the companion galaxy. Yes, of course, that's a destructive force. But the ultimate legacy, actually, is that the gas clouds that get compressed during this interaction, stars can form planets, and the planets may even form life. So this is a beautiful cycle of birth that's synonymous with the universe and black holes.
Our own Milky Way could form its own merger with the nearby Andromeda galaxy and create a new Death Star galaxy, a violent act that would certainly spell doom for the Earth. Such an event would likely occur many billions of years in the future. But there are other stellar threats streaking through our galaxy at high speed. They are hypervelocity stars. Can't stop them. To the human eye, stars paint a tranquil picture in the heavens above. But take an up-close look. A select few are Death Stars on the ocean, and these cosmic beasts are anything but peaceful.
Eventually, a star will burn through all the hydrogen in its core and convert it all to helium. Once it does that, enough to be able to ignite the helium heavier elements like carbon, oxygen, and nitrogen. And this releases an enormous amount of energy. This process is the same release of energy that goes on inside a hydrogen bomb.
Incredibly violent. Most of these stars will one day burn up and slip quietly into the afterlife as stellar corpses called white dwarf stars, smallish balls of electrons and nuclei, or again, burn brightly. But some are supermassive stars, so energetic they end in a fantastic supernova explosion, and sometimes even produce the largest of all blasts, the gamma ray burst. But for a few massive Death Stars, the end is a new beginning. Life of a neutron star. Star explodes in a supernova. Its core sometimes collapses to form a black hole, but much more frequently, it's massive enough to create the black hole. It forms something almost as weird. A small but incredibly dense body.
Has a huge amount of material compressed into a very small space. So you have, for example, the mass of our entire sun is maybe only a couple tens of miles across.
The gravity is so strong that the protons and electrons inside the atoms of the star together to form neutrons. And a neutron star can remain stable for billions of years.
Neutron stars by themselves pose no danger to their celestial neighbors, unless they can find a partner.
You can also get another death scenario for stars where there's a sort of pact between two neutron stars.
These are called co-orbiting neutron stars, a phenomenon initiated when two neutron stars begin an intimate but doomed relationship. Their orbit narrows over millions of years until they finally meet in a flash of light.
They can generate a violent explosion, a second life in a sense.
So there's two different types of gamma ray bursts. There's short bursts, which have durations of less than 2 seconds. And we think that short bursts are produced by merging neutron stars.
The short bursts are different than the longer GRBs produced by collapsing massive stars. Burst emitted by two colliding neutron stars may be short, but it's powerful, equal to the energy released by the sun over its entire lifetime, 2 seconds. The worry for us? Pairs of orbiting neutron stars exist in the Milky Way.
A very nearby gamma ray burst, first and foremost, would get rid of much of the ozone layer. That could have disastrous effects on Earth.
Some estimates hold that a violent neutron star merger occurs within about 3,000 light years of the sun every 100 million years. That's about the same interval as the mass extinction events recorded in the Earth's fossil record. Or should we worry that the last tango of two dying stars might eventually blast the Earth's ozone layer with deadly gamma rays and alter the planet? Scientists don't know the answer. The chances are probably about the same as a runaway star plowing headlong into the Earth. It's a remote possibility. Contemplate.
Possibility that a collection of stars that perhaps were all together in the same neighborhood interacting with each other sometimes ejects a star just to wander off on its own. As far as we know, there are no wandering stars headed our way. But it could be quite interesting.
One scenario could see the Earth's orbit around the sun disrupted by the gravitational pull of the wandering star.
Is that such a wandering star is entirely out of the solar system. And so we're now wandering around the sun. No one really knows what would happen. It really depends upon the angle of approach, the mass of the star.
Wandering stars can travel up to 60 miles per second. Fast, but still not fast enough to escape the Milky Way's gravitational pull. There are some supercharged turbo models that could actually break free and rocket out into the universe. These are called hypervelocity stars.
Hypervelocity stars are normal stars like the sun, except that they're moving out of the galaxy at well over 1 million miles an hour. And that's beyond the escape velocity of the Milky Way.
The need for speed begins with a normal pair of co-orbiting stars that get too close to the edge of a black hole. Just as the disabled Apollo 13 command module got a boost of velocity by maneuvering close to the moon's orbit, the star gets a huge gravitational kick from the black hole, severing the bond with its binary partner.
The star closest to the black hole is captured into a very tight orbit around the black hole. And so it loses this energy. The other star gains that energy and it's ejected with this very large velocity as a result.
The ejection of a hypervelocity star is much like a slingshot effect. The instant the binary star's orbit is broken, the velocity star is launched with incredible force into the void of space.
They've been voted out of the Milky Way, and they're destined to drift into the inky depths of intergalactic space. It's very unlikely that these stars will ever affect the Earth.
Fortunately, the eventual death of these speedy stars will occur far away from our solar system. It's the death stars on our own block we need to keep an eye on. In cosmic time, their fuses are lit, and we have a front row seat to their annihilation. In remote corners of the universe, countless stars are biding their time on death row, sentenced to spectacular, violent endings. Closer to home, stars within 20 light years of the Earth, and a few of these are preparing for death.
I think we're safe from the dangers of a normal supernova. In the case of a gamma ray burst, we're not so sure.
One is in the stellar system Eta Carina, a supermassive star about 100 times bigger and 1,000,000 times more luminous than the sun. 3. A buildup of pressure ignited a gigantic eruption of light seen from Earth. But the star survived and formed a dust cloud called a nebula. At a distance of just 8,000 light years, we'll have a front row seat to its annihilation.
We think it's going to turn into a black hole sometime between now and the next million years. And as it collapses, it has enough matter that it can produce a powerful gamma ray burst.
Unlike the star, Wolf-Rayet 104, Eta Carina doesn't have us in its crosshairs.
The rotation of Eta Carina is not pointed towards Earth. So lucky for us, the pulse of the gamma ray is not going to be directly impacting Earth.
When it happens, the explosion will likely be the brightest supernova ever witnessed by mankind. Unless the title goes to another Death Star contender that's even closer to Earth, Betelgeuse. Located in the Orion constellation, about 500 light years away, Betelgeuse is quickly burning through the last of its nuclear fuel.
Betelgeuse is a very massive star, about 20 times the mass of the sun. And it's within 500,000 years of exploding.
People have been noticing that Betelgeuse has been changing along over the last decades. It's actually shrunk considerably, about 15%. What that means, no one is sure, but everyone's keeping an eye on it.
Some scientists believe Betelgeuse could unleash a gamma ray burst. People on Earth have little to fear if it does. Like Eta Carina, the star's axis points safely away from Earth. Not only that, but Betelgeuse may also have a built-in blast shield.
Its explosion, normal. It won't be a gamma ray burst. Hydrogen envelope in Betelgeuse, and that hydrogen envelope will probably prevent the jet of particles and radiation. There's too much material the jet of radiation would have to pass.
Betelgeuse will shine intensely for a brief moment. To the final moments of our nearest star.
Stars like our sun have nice long lifespans, fortunately for us. And our sun is about halfway through its 10 billion year lifetime. So it's about 4.5 billion years old. That makes it middle-aged.
Scientists estimate that the sun will live another 5 billion years. This could begin much sooner.
Our own sun is very gradually getting more powerful. And within the 500 million, certainly a billion years, it's so hot that the oceans will have evaporated away. So we don't quite have 4 or 5 billion years to worry about this problem. We have to worry about it on time scales of years.
Billions of years after the sun renders the Earth devoid of life, it will enter a final phase known as a red giant. It can't explode and produce a supernova because it's not massive enough. But most scientists agree on the final chapter. Giant, its density will decrease, and the sun will balloon outward, devouring its nearest neighbors.
At this stage, the red giant stage, the sun would probably expand and engulf Mercury, Venus, and maybe even Earth itself. So that would pretty much be the end of Earth.
Of all the dangerous Death Stars in the universe, likely to destroy the Earth, Sun, planet's ultimate end to the cycle of creation. Death Stars take life, but they are also the origin of life.
The heavy elements in our bodies, quite literally, were generated by previous generations of stars and ejected into the cosmos explosions. So we would not be here if it were not for the fact that some stars explode violently at the end of their lives. As Carl Sagan used to say, we are made of star stuff.
As the explosions continue, the resulting heavy elements may one day reseed the very foundations of life, far from the Milky Way, on a new blue planet, in a new corner of In the beginning, there was darkness, and then, in a new corner of the universe. In the beginning, there was darkness.